Hello everyone, this is the last video in the series on chemical reactions for this unit, and in this video we're going to be looking at classifying chemical reactions. So in our first video we looked at the difference between chemical reaction and physical reactions, or chemical properties and physical properties, and we looked at balancing chemical equations. Then in our second video we concentrated on precipitate reactions, which is right here in terms of identifying different types of chemical reactions. And with the precipitate reaction, we saw that we could take two liquids, so two aqueous solutions, and we would get a solid as a product, and that solid is called a precipitate. In our last video as well, we looked at the way to write equations, either a molecular equation, complete ionic equation, and then a net ionic equation. So this video is a follow-up to that, where we now look at identifying different types of chemical reactions. And luckily, we've already got into precipitate reactions in quite detail. The other types of reactions that we're going to be looking at are acid-base reactions, and the classic acid-base reaction is going to be something like vinegar and baking soda, which are so baking soda is the base and vinegar is the acid, and when they come together they cancel each other out to create water plus a salt. Now a salt in this case is going to be an ionic compound, so a metal and a non-metal together, but water is always a product in an acid-base reaction. We're also going to look at gas evolution reactions, and as the name says, a gas is going to be produced and be in the product, so we can look for that. And then lastly, oxidation reduction reactions. That's going to be where we have a metal plus a non-metal, and we're looking at the loss or gain of electrons. That's going to be the main hint that we're looking at an oxidation reduction reaction. And combustion reactions are a subset of these oxidation and reduction reactions, and they're always going to involve oxygen as a reactant. So as we've already looked at precipitate reactions in detail, let's move on to acid-base reactions. So acid-base reactions are reactions that form water when you mix an acid and a base. So when you're looking at the reactants, you're going to have an acid combining with a base to produce water, and it's how you balance out an acid and a base. So in the lab, if you were to spill an acid on the floor, how you'd counteract the effects of that acid and how you would clean it up would be to pour a strong base over that acid, and when they come together, the product is water, which is has a neutral pH and is not harmful. The other product that's formed from an acid-base reaction is formed when the positive ion from the base combines with the negative ion from the acid, and that's going to be a metal with a non-metal. And whenever you have a metal with a non-metal, in chemistry we call that a salt. Now we're used to table salt being sodium chlorine or sodium chloride, but anytime you have a metal and a non-metal in chemistry, we call that a salt. This is called a neutralization reaction because you're neutralizing the acid and the base, which both have corrosive properties, and when you put them together, it neutralizes them to create water, which of course is non-corrosive. So you can see that the hydrogen from the acid and the hydroxide from the base, they combine to make water, and then the metal from the base and the non-metal from the acid combine to create the salt for the product. It really is this product of water that's going to give the biggest hint that you're probably dealing with an acid-base reaction. In this section, we ask you to identify reactions based on hints like this. So when you go to do your test, you're looking at, and they want you to identify the reaction, look for water, because that's going to really tell you if you have an acid-base reaction. The next type of reaction that we're looking at is the gas evolution reactions. And gas evolution reactions, as the name suggests, a gas is going to be one of the products. And it's really easy to identify these ones because you'll see gas as one of the products. And in this case, we have an acid and a base coming together, and it's creating this gas of carbon dioxide, and water is also being produced as well. So not only is this a gas evolution reaction, but it's also an acid-base reaction because this acid, hydrochloric acid, is coming together with the base, which is potassium carbonate, to create water, carbon dioxide, and then the salt, which is potassium chloride. Compounds that undergo gas evolutions are going to have sulfides in them, carbonates and bicarbonates, sulfites and bisulfites, and ammonium. They all give off gas when they are in chemical reactions. And also, when you're looking at stuff like vinegar and baking soda, you can see that there is often a gas that's given off as well. So just remember, gas evolution reactions, gas is in the product, and it can also include acid-base reactions because they seem to give off gas often as well. Identifying an oxidation and reduction reaction, or a redox reaction, can be tricky. This type of reaction can be classified as being a redox reaction if it satisfies one of the following requirements here. So if you have a substance that reacts with elemental oxygen, which means just O2 by itself, then that's going to be a flag that we're looking at, oxidation reduction reaction. When you have a metal that reacts with a nonmetal, so that electrons are either gained or lost, then that's another way to identify a redox reaction. And that again is the idea that we're transferring electrons from one substance to the other. So if you are if you have a reaction that you believe to be a redox reaction, it's because either elemental oxygen is involved as a reactant, you have a metal and a non-metal coming together to create a product, or you can see that you are dealing with either positive and negative ions, so that there is a transfer of electrons from one element to another. So let's look at an example problem that you might come across in your studies. Here we have 4 different reactions that are need to be identified as whether they are redox reactions or not. The first one has 2 magnesiums plus oxygen gas becomes 2 magnesium oxides. And I see that I'm missing some arrows here, so I'm going to put some arrows in. Okay, the very first thing that I see is that I have elemental oxygen here, and when I have elemental oxygen, I know that that's going to tell me that this is a redox reaction. So elemental oxygen is a big sign here that we have a redox reaction. So this first one is a redox reaction. In the second example, you can see that I have water as a product, and that tells me that I'm probably dealing with an acid-base reaction. And looking more closely, I do have hydrobromic acid, and I see this OH. So it does look like I have an acid and a base. So this is an acid-base reaction or a neutralization reaction, and neutralization reactions are not redox reactions. So that I'm going to take out. My next one, I have calcium coming together with chlorine. Calcium is a metal, chlorine is a nonmetal. Because we have a metal and a nonmetal, that's another example of a redox reaction. So this one I'm going to identify as a redox reaction. And then the last one, I have zinc and iron coming together. And what I want you to look at here is that it's given that there's a charge, a positive charge on iron and a neutral charge on zinc to begin with in our reactants. But when you look at the product side, you can see that the charges switch. Suddenly zinc has a charge of 2 positive, which means that it's going to lose 2 electrons, and iron now has a neutral charge. With this, that means that there's a transfer of electrons that has taken place because the charges before the reaction and after the reactions are different. So there must have been a gain and a loss of electrons somewhere during that reaction. And again, this is a huge flag that we're looking at a redox reaction. So this third example would be a redox reaction because a transfer of electrons has taken place. And the last type of reaction that we're going to look at are combustion reactions. And combustion reactions are a type of redox reaction. So think of it as a subset of a redox reaction. Combustion reactions always involve elemental oxygen as a reactant, and that oxygen forms an oxygen-containing compound after the reaction as a product. And this oxygen-containing compound is often water, but not always. Another characteristic of combustion reactions is that they emit heat. So think of combustion reactions that are happening in your car to produce energy. They're creating heat. And compounds containing carbon and hydrogen, or carbon, hydrogen, and oxygen, always form carbon dioxide and water upon combustion. So if you have on the reactant side carbon, hydrogen, and oxygen, then on the product side you're going to see carbon dioxide being formed and water being formed. So we have a gas reaction happening here as well, along with the combustion reaction. So here's an example of a combustion reaction. CH4 is natural gas, and when it's combined with elemental oxygen, you can see that carbon dioxide gas is released and water is formed in the liquid form. This is considered a redox reaction because we do have elemental oxygen as a reactant, and because gas is being released in the form of carbon dioxide, this would also be a gas reaction as well. And here's another one. We have C8H8, and this is the fuel octane. And octane, when it is reacted with elemental oxygen, creates carbon dioxide gas and water. And from these fuel reactions, these combustion reactions, you're going to have heat and energy being produced from the reaction. So we show that with a squiggly line or a squiggly arrow to show that heat and energy are produced through this reaction. So combustion reactions are going to form heat. They're going to form gas in terms of carbon dioxide, and they are also going to form water. So that is all the chemical reactions that we cover in the unit. Again, knowing the properties or the characteristics of each of these reactions are going to help you to identify whether a chemical reaction is going to be one of these or not. So have fun with it, practice, and thank you for watching. Bye for now.